recommend that you actually list what the points are, because then you're not going to miss them, right? If you put them out there, it'll be fine. Okay, questions about the quadratic formula? You will have to use it in this course and in grade 12 in calculus and beyond, okay? You will have to use it. So if you don't have it memorized, you should get those football plays, Andrew, and get the quadratic formula, and then instead, all right, Taylor, not a joke. Okay, I'm sorry, Taylor. Okay. Next one's going to be my vertex. Okay, because I want you guys to be strong completing the squarers, is that a word? It's going to be minus 6x minus 1. I'm going to hit pause in the video. I'm going to give you guys about 2 minutes to find the vertex. Okay? Yeah, go ahead. Okay, good. So y equals? Yeah. Yeah. Now, I was talking to George, I hope you don't mind me sharing our conversation with the class. He basically said, we'll be graphing this to decimals anyway, right? Like, how do you graph a fraction? It's difficult to do. And I said, yeah, it's okay to change the decimal for your final step. The thing is, in this class, very rarely we'll be doing graphing, though. Not very rarely, but a lot of it's completing the square stuff we're using fractions for, so I want you to be comfortable in using it with your algebra for fractions. Logan,
yeah.
Next step is what? Go ahead.
Draw the arrow.
Good.
And put -3 over 2.
Yeah. Yeah.
So you're going to do that as fraction.
Good.
Okay. So you underline negative.
Yeah. Good. And what is -3 over 2 squared?
9 over 4.
9 over 4. If you did 2.25 and -1.5, that's okay for today. But as we progress in this course, that being Monday, decimals should be gone.
I'm fine with it.
All right, Gabriella, can you please be brave and try and give me the next step here? Go ahead. Yeah. Oh, yeah. Yes, right. Okay, guys, just wait, please. Thank you very much. That's good. Okay, but you're doing exactly the right thing. So what you said, I'll share with the class. Can you please give me some of that? Okay, so Gabrielle also gave me the next step. So what she did was she multiplied this by 2 and called it -18 over 4. Right. You could also do 9 over 2 if you like that better, either one. I'm going to do one thing here, and I want, before everyone's jaws drop, I'm going to do this right there. Can someone please tell me what just happened? Callum, go ahead.
Because it's -1, so you just put it in.
Yeah. Why did I want to put it into a fraction? Yeah.
Because you're subtracting it from a fraction.
Right on.
Put it into a fraction.
Yeah, common factor, like a common denominator, right on. Okay. I'm going to change that to halves in a sec. Okay. Now, this is the magical part. Caitlin, can you do it? Can you factor that bracket? Yes. Yeah. That's squared. Not x squared taken with 3 halves, like x minus 3 over 2 squared. And I'm going to call that -22 over 4. I don't like that, so I'm going to call that y equals 2 bracket x minus 3 over 2 squared minus 5 over 2. Okay, please be brave. If something's not clear, please ask. Ben, all good? You got to sit in the front row. I'm going to move you up. Oh, you like how you're happy in the back? I'm going to start making football jokes. No, I'm not going to. Okay, what is my vertex? Who are we up to? Brooke. Oh, sorry, which part?
-4.
Okay, the question was, okay guys, can you please just stop for 1 second? Go ahead. That was easy. Okay, Brooke, what is my vertex and which way is this open, please? Okay guys, I can't talk when you guys are talking. Okay, Brooke's vertex is what? Which way does it open?
3 over 2.
Yeah. That stays negative though. And we're opening upwards or downwards. Okay. Feeling somewhat okay. Okay, my other key points are going to be, I'm just going to write these here just because I don't like to keep it all together. Was it 0 and -1? Ignore my roots. 3.15 and 0. You're right, this does take a long time. When you get to calculus 2 years from now, you're going to be mad at Mr. Sadler because you can do this in about half a second. So I'm going to say fine, 30 seconds. Calculus. Isn't calculus awesome? Yes, it is. It makes all of your high school math go speed up. It's like 10 times faster, like at least 20 times faster. Because the problem is, like, you got to know all the algebra fundamentals and stuff like that. It blows you away. Like the math is difficult, but once you can do it, it speeds up all this stuff. Does that make any sense? I'm a math teacher. My degree's in math. Yes, I can do. All right, I'm going to graph this right now. Okay, if you're fading out or wishing that the class was over, Colton, what we're going to do right now, I'm just joking here if you don't wish the class over. What I'm going to do is I'm going to go through exactly what I want for a graph. Whenever I do a graph in this course, there's probably going to be on your final exam 6 or 7 graphs. Each one will be worth about 10 marks. Okay, probably at least 4 or 5 marks for each is just on format. So I'm going to go through quickly. If you are somebody who has a graph like this, okay, and hopes to get full marks, you are going to be in pain in this course. Okay, so do not let it be you. If you're in my grade 9 class, hopefully nothing's changed since grade 9. If you're in my grade 11 class, nothing's changed since you. Thank you. Here we go. There we go. Okay, here's the graph. First of all, you're going to use graph paper. As I was saying before, if you don't have graph paper, please get some. Okay, so if you don't have graph paper yet, have some by Monday. If not, then the angry phone calls are going to start coming home to your parents. So the main thing, guys, can I please do this? Okay, so we're going to draw our lines here for the big line here. You have to make sure that your graph, everything fits on the graph. So you got to look at sort of the main, like the range of their numbers to find out what's going to hit on. There was a girl, sorry, I shouldn't be sexist. There was a boy or a girl, I can't remember, who had an assignment in this class, and there's one point at like 200, another one at like -250. And what she did was she taped 4 pieces of graph paper together so she could fit all the points on the graph. Don't do that, please, okay? Change your scale and make wise decisions as you're making a graph to make sure it fits on there, okay? That isn't a joke, it's a serious thing that happens. Awful, yes?
If you have your graph going up and line, does it have to go over by?
No, good question. The question from Madison was, and this is a good question, if I'm counting my y values by 5, my x values have to scale the same, no they don't. And for this right now, like, this I'm going to get between like -0.5 and 3.5, so I'm probably going to have every square is 0.5 going left and right. And my biggest point for y looks like 0 and to -5.5. So how would my line go? So I'm probably going to do a graph sort of like this, and probably sort of like this. Okay. The reason I can get away with that is I have no positive y values, right? Not 1. Okay, so although you didn't see it, I actually used a ruler for that line, so that you should be doing. If you're someone who's not a fan of a ruler, most people should have a ruler by now. If you don't, the person beside you does. Okay, so you should make a straight line. If on your test you don't, there's going to be major problems. Okay, every math teacher I think is the same, and we all require most of the same things. What else, Taylor, should go on this graph before I continue? X-axis, y-axis. If you don't like to write fully x-axis, y-axis, you just want to write x and y, I can live with that. Who else have I taught before? Last, what else do you need in this graph? Arrows. I need arrows everywhere. Okay, Sarah, what else do you need on this graph, if anything? Numbers, okay? Now, as we said before, the scale doesn't have to be the same, so I just have to get over to 3. I'm going to count every point. this should be 1.5. I use every other line as 1. That's going to count every other line as 1. Yeah. Now, the question that Madison was asking was a good one. She said, does the scale have to be the same? And no, it doesn't. Okay, if I use left and right, I use every 2 boxes were counted as 1. I'm actually going to use the same scale on this one, but you don't have to. Okay, so I can do the same thing. There's -1, -2, -3, -4, -5, -6, -7. Okay, that graph is looking good right now. This is pretty much the same as your grade 10 teacher, I hope, made you graph, I hope. If he or she did not force you to do that, shame on you, because you answer. Yes, Madison, question. You do need a title. I'm going to do the title probably at the end, though, because you can do it at the top and say graph of y equals whatever, but I'm probably just going to write it right beside where the line is. Okay, next we're going to do our graph, our points. If you remember, the points always go, just a reminder, they go x and y. Okay? So it's going to be, first point is going to be 0 and -1, so x is 0, y is -1. X is -0.16, that's going to be somewhere about there like that. 3.15 is going to be somewhere like this. And then we have 1.5 and -5.5, which is going to be something like that. Okay, can somebody tell me 2 reasons that looking at that visually, that's okay for a vertex, that looks good for a vertex? What are the 2 reasons that's good for a vertex? And that's, go ahead. It's between the roots. The vertex has to be in the middle of the root. So I have 1 root on the left, 1 root on the right, the vertex in the middle. What is the second reason that it's got to be the vertex? That makes sense for a vertex. Oh my goodness. 1 whole week. Why does that have to be the vertex? Why, if the vertex was like here, would that be wrong, or up here? Why is it there? Go ahead.
Because it's in the middle of the 2 x-intercepts.
Good, she just said that. What's the other thing, though? Sienna. Oh, okay, because what happened, I just converted this over in my head to decimal. Right, so that's, what he's telling me? Yes, it opens upwards. So this is your lowest point, right? So because this is your lowest point, it should go sort of like this. Sort of like that. Okay, someone else who's been in my class before, what else has to go on this graph? Oh, sorry, go ahead. Question or answer? I just seem to have it in my class. What else should I do this graph? You guys are so enthusiastic about graphing. You learn to love graphing because there's going to be about 10 of these. Yes? Arrows on the end of the graph, always. Y equals 2x squared minus 6x. Minus 6x? Right? There's the equation. And that's enough for a title. If at the top of your graph you want to write Kirsten's wonderful graph of awesomeness, y equals 2x, that's fine. Okay. As well, in your homework, if you want to put 3 or 4 lines on the same piece of graph paper, that's fine too, but just make sure that you distinguish which one's which. Okay. I think I'm going to stop there and just give you guys 4 graphs for homework, and that's going to be that. Okay. Questions or fears about that? 4. Didn't you guys do this in grade 10? You never graphed a problem in grade 10. You guys all graphed a problem in grade 10, and don't tell me you did. What's that? You guys did graph in grade 10. I know you did.